Okay, here we deal with a more complicated version of the percent yield example problem. How do we know, short of having a label like this, how do you know this is asking for percent yield? Well, first of all, it asks you the percent yield. But what other characteristics are there that gives us away? Well, for one, let's look at this. It tells you how many grams of toluene, that's a reactant. It tells you how many grams of nitric acid, that's another reactant. And then it tells you how many grams of one of the products that you actually got. So guess what? This is your actual yield. This is the amount of each reactant, and you need to use these to calculate the theoretical yield. And you're going to take the theoretical yield and compare to this in order to find the percent yield at the end. So, let's do this. I will lead you through an example for this first one, and then you, the viewer, pause the video later on, work these two questions out yourself, and at the very end I will show you the full worked out solutions for each of them. So, to begin with, and let's grab a blank piece of paper for this, let's work out this first question. Okay, so need to figure out the theoretical yield so that I can take that and do a calculation with this to find the percent yield, because that's what it's asking for. This one is asking for the percent yield. So, okay, first thing I need to do in order to do anything is to balance this equation right here. So let's have a look. 7 carbon, 7 carbon, 9 hydrogen, let's see, 7, 8, 9 hydrogen, 1 nitrogen, 1 nitrogen, 3 oxygen, and 3 oxygen. So this equation is already balanced as written. So good, I can leave that alone and move on now to the next step. Okay, it will be necessary to do two calculations, one using this and one using this, and then choose the smaller number, and that'll be the theoretical yield. So you know what? Let's do that. 550 grams of toluene, okay? 550.0 grams of toluene, C7H8. Let's do a calculation with that and see how much product it should make. But wait, which product? Well, let's see. I'm told how much p-nitro-toluene it makes. So that's what I'm going to need to do. I'm going to have to calculate grams of C7H7NO2. And I'll do the same thing for the other chemical reactant involved here. So just setting up the equation piece there. So the other chemical reactant, nitric acid. Okay, so then let's put in the 330.4 grams of nitric acid. Uh-oh, seems I've had the pen die on me. Okay, we'll continue with another color. Okay, and this too will be solving for some number of grams of that one product, C7H7NO2. Alright, so here's where we do the same kind of calculations that we were doing earlier to predict how much product should be made. And we're going to choose the smaller of the two answers and compare it to this. So, alright, here it goes. Let's see. 1 mole C7H8 has a mass of 92.13 grams. And then in the equation there's 1 mole of it, so 1 mole C7H8. As for our product, there's also 1 mole in the equation, so 1 mole of C7H7NO2. And then here we need to go back to grams, so we're going to use the molar mass, where 1 mole of C7H7NO2 has a mass of, 137.14 grams. That's what I worked out earlier anyway. C7H7, NO2. Alright. and then you calculate that through, and the theoretical yield based on this reactant would be 818.7 grams. 4 significant figures because 4 significant figures here and 4 significant figures here. Here it is, let's fill this in, 1 mole HNO3. That has a mass of 63.02 grams HNO3. In the balanced equation, there's 1 mole of HNO3, shown here. And as for our product, also 1 mole. Let's see, there's C7H7NO2. And then, final bit, molar mass. 137.14 grams C7H7NO2 over 1 mole C7H7NO2. Whew, so that's that setup right there, and then the actual number that came out when I calculated that earlier was 718.1 grams, where this divided by that times that came out to that. Again, 4 significant figures. Alright, so between the two, I'm going to choose the smaller number, which is this one, as the theoretical yield. And once I have done that, I can then take this and, let's see, I'll have to scoot this out of view. There you go. That should more or less keep things still in view for you, the viewer. Okay, I can take the theoretical yield and compare it to the actual yield. So as a reminder, percent yield, I'm going to check the, okay, good. Percent yield equals your actual amount produced divided by your theoretical yield. And since that's a decimal, you need to times it by 100%. Okay, so the percent yield here is going to be your actual yield of, according to this, it was 515.8 grams. Divided by our theoretical yield, which is the smaller of these two calculated numbers, 718.1 grams. And when you run that on the calculator, well, let's see, I'll show you. That's your percent yield. Now, let's round that to the correct number of decimal places. We got 4 sig figs here, so we'll need to pick 4 sig figs here. So we'll call it 71.83% yield. 71.83% yield. Alright, now on a test, if the question is asking for percent yield, make very sure, especially if you box this for your own convenience, that it's really clear that this is your percent yield. Okay, make it clear that this is your final one. Like maybe put 2 boxes around it just to make it super clear that this is your final answer. Alright, so that's basically the full process there. And what we've seen is that basically what you actually got was about 71.83% of what you thought you were going to get according to this calculation. Now, that's the full process for working this out. Let's return back to those problems I had earlier for you. Okay, so I've shown you the solution, right? You've seen the solution here. Pause the video because I want you, well, okay, you're going to pause the video because I want you to work these out. And in a moment, I'll put up the fully worked out solutions. And I'll assume that you've paused the video and worked these out. Here come the fully worked out solutions. Okay, let's see. Here's the first of those ones. So here's problem number 2. Now let's make sure this is in full view for you, the viewer. Okay, so I took the amount of each reactant, calculated the theoretical yield based on them, chose the smaller number that I was going to work with for the final calculation. Percent yield is actual over theoretical. So here's the theoretical yield down here at the bottom, and here is the actual yield here on top. Divide it out, times by 100. Because actual yield is greater than what you're expecting, the percent yield's over 100%. Now for the other one. Okay, there we go. So, once again, took the two reactants, calculated how much product, chose the smaller number as the calculated theoretical yield, and then took that number and put it together with the actual yield up here. So here's the actual amount produced. Here's what we expected to be produced. So the actual amount goes on top. The expected amount goes on bottom. And you divide them out, times by 100%. What you actually got was about 91.5% of what you thought you were going to get. All right, so there you go. That's how you study, or that's how you calculate theoretical yield and use it to find percent yield. Any questions? Consult a peer, consult your teacher, or various other resources available to you online. So there you go. Happy studies.